Hi everyone. In the previous sections, we learned each step of the hypothesis testing process. In this lesson, we are going to put everything together by completing a full hypothesis test from start to finish using the TI-84 calculator. Let's get started with example 1. A nutritionist claims that the average sodium content of frozen meals is less than 750 milligrams. To test this claim, a random sample of 40 frozen meals is selected. The sample has a mean sodium content of 720 milligrams and a sample standard deviation of 90 milligrams. Assume the sample is randomly selected. At the 3% significance level, is there sufficient evidence to support the nutritionist claim? So, what is the nutritionist claim? Their claim is that the average sodium content of frozen meals is less than 750 milligrams. We're working with the average, which is the population mean, which is mu. And the phrase less than 750, that means our original claim is mu less than 750. So I want to test to see if there's good enough evidence to support the claim that the mean is less than 750. Step 1. Let's identify the null and alternative hypotheses. The original claim is mu less than 750. This statement does not contain the equality sign, so this is my alternative hypothesis. The null hypothesis always includes the equal sign, so I have mu equals 750. So this statement means that the population mean sodium content is less than 750 milligrams. And this statement means that the population mean sodium content is equal to 750 milligrams. Step 2. Identify the significance level alpha. The problem tells us to use a 3% significance level, so alpha is 0.03. And we also need to determine the test type. Let's look at the alternative hypothesis. It contains the less than symbol, so this is the left tail test. Step 3. Verify the assumptions and choose the appropriate test. The problem tells us the sample was randomly selected, so the randomness condition is satisfied. We are testing a population mean, and we're given the sample standard deviation, not the population standard deviation. That means we'll use a one sample t-test. Step 4. We'll use the TI-84 calculator to perform the hypothesis test and find the p-value. Now, let's use the TI-84 calculator to perform the hypothesis test and find the p-value. Press Stat, arrow over to Test, select the second one, t-test, and press Enter. Since we're given the sample statistics instead of the raw data, we'll choose Stats, press Enter. Now, let's enter the information from the problem. For mu0, enter 750, because this is the hypothesized population mean from the null hypothesis. For x bar, enter 720, because that is the sample mean from our sample. For Sx, enter 90 because that's the sample standard deviation. Remember, we're entering Sx because the population standard deviation is unknown. For n, enter 40 because that is our sample size. Next, we choose mu less than mu0. Press enter to highlight it. We choose this because our alternative hypothesis says the population mean is less than 750. A good rule to remember is that the symbol you choose on the calculator should always match the alternative hypothesis you wrote in step 1. Once everything looks correct, highlight calculate and press enter. And this is our result from the calculator. This is the result from the calculator. From this result, we get the test statistic and the p-value. If the question asks for the test statistics, this is the answer. If the question asks for the p-value, this is the answer. So in this problem, we're looking for the p-value. So we'll have p-value equals 0.020746. And let's round this to 4 decimal places. So we get 0.0207. Step 5, we need to make the decision and write the conclusion in context. In order to make the decision, we compare the p-value with alpha. If p-value is less than alpha, we reject the null hypothesis. If p-value is greater than or equal to alpha, we do not reject the null hypothesis. P-value is 0.0207 and alpha is 0.03. Is p-value less than alpha? Yes. So we reject the null hypothesis. Always make sure to justify your answer. Now, let's write the conclusion. HO states that the population mean equals 750. HA states that the population mean is less than 750. Which one do we support? Look at our decision. We reject HO. That means we do not support HO. That means we will support HA. So there is sufficient evidence to conclude that the average sodium content of frozen meals is less than 750 milligrams. Notice that we don't say we've proved the nutritionist claim is true. Instead, we say there is sufficient evidence to support the claim.